Hello, welcome back for another lesson. Today is January 12th, and we are studying the relationships of operations. That sounds like it's going to be complicated, but it is really pretty simple. So there are just two goals, and goal one, understand the relationship between addition and subtraction. Goal two, understand the relationship between multiplication and division. So we're going to be doing two different types of problems, but they have similar tendencies. So make sure you pause your video whenever you need to copy down these notes. The semester is ending in a few weeks, and you'll have a big test on February 2nd. All right, so for our key notes, and we have notes written twice, so let's get rid of that. Addition and subtraction are opposites, and that's going to be really important to understand as we move forward with these expressions. If you add $5 to your bank account, that is a plus 5. If you take away $5, that is a minus 5. And positive 5 and negative 5 are opposites. So addition and subtraction are opposites. They do the opposite thing to your current number. Multiplication and division are also opposite. If you triple something, right, that means you're multiplying it by 3. If you cut something into thirds, you're dividing it by 3, and those are opposites. It sounds really simple, and these problems that we go through are going to feel simple, but once we get to equations with variables, it's going to be really important to understand why we can manipulate our equations. So if we look at our first little example, we have sort of a weird problem. We have 10 and then plus 6 minus 6. So we start with an original number, which is 10, and we are adding 6 and then subtracting 6 right away, which I know doesn't make a lot of sense in this context, but if we did this addition and subtraction, we would say, well, 10 plus 6 is 16, and then we'd have 16 minus 6, which would equal 10. So we would get back to our original number. And that's going to be really important to understand when we do equations. So we have taken a number, and when you add a number and then subtract that same number, all you're going to be left with is your original number. So we could have picked any number besides 6. We could have done 10 plus 100 and then minus 100 and still ended up with 10 because addition and subtraction are exact opposites. So similar problem here. We start with 8, and we have 8. We take away 3, and then we add 3 back. So we know that 8 minus 3 is 5. We add 3, and we get back to 8. So the order has changed. We have subtraction, we have addition, but because those are the same number and they're opposites, they cancel each other out, and all we're left with is our original 8. So if you are trying to get rid of something, you need to add it to cancel out the operation. So if we want to get rid of the subtraction of 3, we need to add 3 because those are opposites, and those opposites are going to cancel out. Over here, I'm not sure why it's in the middle. That happens sometimes with the multiplication and division operations. We are taking 4 times 2 and then dividing by 2. So 4 times 2 is 8. And if we divide by 2, we get back to 4. So very similar to addition and subtraction, we have these opposites. If you double a number and then cut that number in half, you're going to get back to your original answer. So all we had to do was do something and then do the opposite, and we get our original answer by itself. So this will be useful when we are isolating a variable or a number. If we're trying to figure out what x is equal to, we want to get x all by itself. So, examples. On your assignment, you're going to have some of these. It says, copy down each equation, but replace the question mark with a number to make each equation true. So there's only going to be one correct answer for each of these because 3 of the 4 numbers are given. So number 1, we have 9 plus question mark minus 5 equals 9. So we want to notice first that we start with 9 and we end with 9. So whatever happens to the 9 has to cancel each other out. So we have an addition problem and then a subtraction. And if we're subtracting 5, that means we need to do the opposite of subtracting 5 to get back to 9. So that, of course, would be adding 9. I can switch colors maybe. And we can test this out. We could say, yes, 9 plus 5 is 14. And then if we subtract 5, we get back to 9. So all I did was I copied down the equation and I replaced the question mark with a number. All right, number 2. Again, we start with 12. We end with 12. So whatever happens in the middle, they need to be opposites. So the opposite of minus 4 is going to be plus 4. Because we want to get back to our 12. We want that 12 to be by itself. 12 minus 4 is 8, plus 4 is 12. So these are pretty simple to check. All right. Number 3, 4 times 2 divided by 2 equals blank. We can see that these two operations are exact opposites because we're multiplying and then dividing by the same number. So that means we're going to end up with our original number. So I can write 4 times 2 divided by 2 equals 4. And I know that's true because 4 times 2 is 8, divided by 2 is 4. I think we got one more example. We have a question mark, and then divided by 3 times 3 equals 15. Again, I'm looking here. I see that these two are opposites, so that means we're going to end up or start with the original number. So that means that 15 divided by 3 times 3 is equal to 15. And this 15 should be in a different color. So these are just patterns. I'm sure you have noticed the pattern by now. And once you get to the algebraic equations, you're going to be using these patterns to simplify your problems. Good luck on your assignment. Let me know if you need help.